everybody. Hopefully you have finished the definitions. And so what we're going to do now is we're going to look at some examples. So hopefully you remember this example we've seen before. It's called warming and cooling. If you remember, the x-axis was time in military time, and the y-axis was temperature in degrees. So the first question is it continuous or discrete? So remember, continuous are measurable values like temperature, and discrete are countable values. So this is going to be continuous. This also means that every value on the graph from the beginning to the end makes sense. The next thing we want to talk about is domain. So the domain, because it's continuous and we want to include the endpoints, we're going to use the hard brackets with the smallest x, which is 0, to the largest x, which is 20, followed by hard brackets. Remember, the other way that we can do this is we can use inequality notation. So we can do 0 is less than or equal to, give me just a second, x, because we're talking about the domain values, and then is less than or equal to 20. So interval notation, which is this 0 to 20, or inequality notation, those are both the same for the domain. Now the range is very similar. Again, since it's discrete, we're going to write it in a similar way. So let me just copy and paste this. The smallest range value is actually 60. So don't get tricked by the fact that the graph goes down here to, let's say, 20 and goes all the way up to 100. We only care about the actual curve. So the lowest that the y value goes is 60, and the highest the y value goes is 90. In fact, we actually call that the minimum and the maximum. So let's go change these values. So 60 is on the left-hand side, 90 is on the right-hand side, and I need to change my inequality to a y since we're talking about the range. So note, we can actually say that the minimum value is equal to 60, and the maximum value is equal to 90. So those definitions weren't given earlier, but it makes sense that the minimum is the smallest y, and the maximum is the largest y. So the x-intercept, we're going to use the graph to determine our answer here. So the x-intercept is the point where it crosses the x-axis. Well, since the graph doesn't cross the x-axis at all, I'm actually going to write none. If you write 0, that implies that it actually crosses at 0. And then the y-intercept is where it crosses the y-axis. So that's at the point 60 for the y, or the point 0, 60. Now, those are all the interesting characteristics right now for this graph. So let's go ahead and look at the next graph. So example 2 is a little bit different. As you can see, it is a line and it has arrows at both ends. The fact that it has arrows at both ends implies that it goes on forever in both directions. Now again, we know that it is continuous because it is a connected graph. All right, so let's talk about the domain. Now, domain is x values. So it's saying that as you go left, does the graph continue to go on? Yes, it goes left and up. Does the graph continue to go to the right? Yes, it goes right and down. So the domain is actually all real numbers on the x-axis. So we can write that as all real numbers, or there's a symbol, which I'll try to go find later, which means all real numbers. Or we can also use interval notation, that x goes from negative infinity to positive infinity. So let me just go insert a special character. And if you didn't know this, you can actually do a little drawing. And I can see the infinity sign is right there. So I'm going to go ahead and put that in. So from negative infinity to positive infinity. So again, that's a fancy way for saying all real numbers, or that it continues as you go left and right forever. So range is also very similar. It goes up and down forever, so it's also all real numbers, or negative infinity to positive infinity. Now remember that negative infinity to positive infinity is called interval notation. There's not really a way to write it as an inequality here. All right, so the x-intercept, where does it cross the x-axis? In fact, it actually crosses both the x and the y-axis at 0, 0. So this is at the ordered pair, 0, 0. For both of these are the same. Now, in behavior is a little bit confusing. And if you'll give me just a second, let me pause the video. Or not. Okay, so we're going to just keep on going. So, in behavior is a little bit different. So we're going to start with as the graph goes to the left, or as x goes to the left. What happens to the y values? The y values get larger or go to bigger and bigger and bigger infinity. Then we ask ourselves, as x goes to the right, or as you go to the right on the graph, what happens to the y values? The y values actually get smaller. Now, I think this makes sense to most of us, but now we're going to write it in interval notation. So, a fancy way for saying that x goes to the left is we're going to say as x, and we want to get our arrow for approaches. It's always, let's see if we can get this, it's always a right arrow, even if you're not going to the right. So we can see here that x approaches infinity. And I believe, I don't want all that. So as x approaches infinity, sorry about that. So again, remember if you go to insert special characters and you draw, it'll come up. A handy little tool if you're doing something electronic. So as x goes to the left, now x is actually going to negative infinity. So that's a fancy way for saying x goes to the left. Y gets larger. So I'm going to say y approaches, and it's going to be positive infinity because it's getting larger and larger and larger. Now I'm going to copy and paste just for time's sake here. Now we want to say that x goes to the right. So x is actually going to go to positive infinity, get larger and larger and larger, and this time y goes to negative infinity. So this notation right here is what you're going to write for in behavior. Sometimes it helps me to think about this in words first, but you need to be able to translate. All right, take a breath. We're going to go into example 3. So what do we know about example 3? Well, hopefully you know by now that it is a discrete function. Remember, that doesn't mean that it doesn't go on and on forever, but it does mean that it's just dotted, it's disconnected. This is probably something countable, like number of tardies, number of fleas, and so on. Now, domain, since it's going to be discrete, is we're going to use the curly or the funky brackets, as I like to call them, and we're just going to list out all the x values. So we've got 0, 1, 2, and 3. Now, if I knew this graph went on and on, I would put the dot, dot, dot. But we don't know in this case, so we're just going to leave it with what we can see. And then the range are going to be all the y values. And again, we're going to use the funky or the curly brackets. The lowest y value is 1. And then we have 2, 4, and 8. So again, we're just going to simply list those out. The x-intercept is where it crosses the x-axis. Now, since it doesn't cross the x-axis, remember we're going to write the word none. And then the y-intercept, let's write as an ordered pair, is 0, 1. It's where it actually touches the y-axis. All right, we're not going to talk about in behavior because it's not really interesting on this graph because it doesn't go on and on and on. Now, on this last thing, we're going to talk about the domain and the range, the x-intercept, y-intercept, and in behavior. Now, I'm not sure where my domain went, so let me type that in here. Now, I asked you to put arrows on it because I want you to realize that the graph goes on and on forever. So let's think about this for domain. How far left does this graph go? In other words, if I kept drawing this, if I kept going left, would it keep going? Yes, it would go left and up. So we're going to say the domain is from negative infinity. Let's go see if my infinity sign is still there. Yep. So negative infinity to positive infinity. Remember, that is a fancy way for saying that it's just all real numbers. Now, you keep hearing me say all real numbers, and you're like, well, aren't all numbers real? They're not, but for our sake, all the numbers that you deal with are real numbers. Okay, I'm going to stop here for now, and we'll come back to example 4 in a little bit. Thanks.